Welcome back, dear friends, to part 3 of the Steampunk penny arcade machine. Thank you for your continuing support and so many suggestions. It's great. I'm now well, let's just slow down a little bit. Let me just recap what we've got done so far and since the last video. Evolution and hindsight. Great things. There's the first one, and we'll use the lever, and the ball coin had to be strong enough to lift the lever to roll the coins off, because I want it to work with all the full range of coin diameters and weights. It didn't work. I could get it to work with heavy coins or light coins, but not both. Number 2, which I was absolutely thrilled about, because this one, and I've taken some of the parts for version 3, this worked because this had a pin sticking out that would hold the coins in place, and then that made it much easier for the coin, for the ball to lift it and release the coins. Thrilled with that. Got that put onto here, in there, because it's on its side, and it kept sticking all the way down, and I was thinking, well, it's hanging a bit too low, as you do. So, version 3. I moved that down, and look, 2 bearings, because this handle kept getting stuck, because it's sort of being bent backwards by the weight of this. 2 little bearings, again, oh, what a joy. And now it slides up and down perfectly, and I think that's the only change I made. Everything else still works on its beautiful like. Then, yesterday, of this very today, I started working out where to drill the slot, cut the slot for the coins to go through, which will be there. All sorts of complicated calculations and angles of dangles later, and having decided stupidly to do it on the pillar drill, and having spent an hour or so trying to turn the platen of the machine to 22.5 degrees, and what a palaver. I'm drilling in a 38mm eel instead. How much simpler is that? Straight through vertically. Can you see where we're going? Did you spot this just now? Look, it's an insert, an angled insert, or an insert with an angled hole down the centre for coins to run down. How fantastic, because I was thinking, I was so excited by this machine, I think I'm going to be making quite a lot of them. There's just not enough space in my machine for all the ideas that I'm trying to suppress at the moment. So I thought it was worth doing that. I'm going to drill a hole, get that in, then I'll get back to you and stop talking quite so much. What a joy. I made this because the 3D printer is generally 0.2mm oversize. So I made that 0.2mm less than 38, drilled 38mm hole, and it just pushed in beautifully. And it seems to line up. I haven't tried it yet. Let's try it now. Here's my collection of coins. Let's start with the biggest first. £2. Yep, that's good. Let's try the smallest, which is a 5p. Pop that in there. Is it in? Let's lift it up. Yes! What about a strange bendy angled 50p? Yes! Fantastic, I'm so pleased. A little artistic shot. Just noticed it with the sun shining through the tree leaves, glimmering onto the mess that is here. Now I need to work out how I can slow down the coin ball thing from when it's falling down, because obviously if I release it straight away it's going to crash straight to the bottom, and if I've got mechanisms like an airship possibly moving from left to right with some mechanism, it's going to go like that and then it stops. So I need to slow it down. 2 things come to mind, and thank you for all the people who suggest in comments using eddy currents on a really big magnet, but that means I'd need to have started a different way. So I'm going to stick with this idea. I've got 2 ideas. That's 2. One, the first, is to use eddy currents, but in a funny sort of way. I've got a little motor, and I've built a test jig because I want to just get my head round. I know you could probably calculate it all mathematically, but I don't know how. It's much more fun doing an experiment to get my head around it. A little motor there, but a good quality one, a low voltage one. What I've done is short circuit it, which means the electricity it produces when it's turned, acting as a generator, feeds back into it and sort of tries to turn it as a motor but in the opposite direction, so it slows it down. I've got that with a pulley and a thing and some fishing wire and some weights on the bottom. Let's try it first of all with it not short circuited. So one red, I'd say that was half a red bus. I'd say that was half a second. Now let's connect this up so it's short circuited. Red bus is at the ready. One red bus, two red bus, three red bus, four red. Oh, isn't that amazing? God, that's really exciting that you can have that much effect. However, there are a couple of issues, as always, with everything to do with this project. The fact is, it's going to be reliant on the mass, whatever weight it is trying to, it's trying to be turned by, and the gearing. So I'm not sure, because my second plan, which is a particularly cunning one, even though I say so myself, is to use a pendulum and an escapement. There are two really good benefits with this. The first is it doesn't matter what mass you have, what weight you have, the pendulum will always release it at the same rate, which is fantastic, because I don't know until I finish building everything just how much of a weight or mass I'll need to get all the mechanism working. So that's great. The second thing is, what's brilliant about that idea is I've been thinking about how to score it, and I was thinking about airships going across and balls falling in them and different slots falling down into clouds. Needless to say, I'm sorry there are no drawings, it's in my grey matter. And all sorts of complexities, and think, how the hell am I going to be able to actually score this? And someone on YouTube, I'll put the name on the screen, suggested using a clock as a scoring system. Now, it's not going to have two hands because that's too complicated, at least at the moment, but it's going to have a dial, and I think it might be sitting on top of the cabinet, and it's going to have a pointer like an hour hand, and it'll go around and it'll tell you what your score is, and it should hopefully too much time taking the dog for a walk, not thinking about the dog. Theoretically, when you put a coin in, it resets it back to zero with some sort of little coil spring, and then obviously once you finish the game you can sit and admire whatever score you've got until the next person puts a coin in. And I was thinking, how could you get it to go forward and all this? Just make it time. It's as simple as that. The whole idea, the concept of this game is to keep the ball in play for as long as possible. So each time you lift it and let it go, it carries on moving the pointer whichever way you are, so that way, around slowly, reaches the bottom, lift it up again if the ball's still in play, carries on counting down. Once the ball goes out and you can't lift it again, that's it, that's your score. There's a few bugs to iron out, I'm just realising as I'm explaining it, but I think that's very exciting. Look at this lovely big ball chain, it's huge, and I haven't reused it that much because it's quite large for my current machines. But my plan is to have a piece that goes from the lifting thing up here, over a pulley, up into the clock mechanism here, over here, down another pulley with a counterweight this side, which, as someone else pointed out, could also have a lifting system on, so if the ball comes down and falls in while this is still going up, because that's going down, it can lift the ball. Oh, I tell you what, and I can really visualise a nice circular clock type scoring system on the top. I think that would look lovely. Why fiddle and fart around with a prototype when I know where the chain's going to go on the real thing? Put it on. I don't know how I'm going to slow it down or what I'm going to get it to do, but I know where it's going to go. And then I had a look at my drawer of plastic bearings which have been unused for many years. Obviously I've got the 5mm diameter ball chain, this is 8, so, and I've got some 8mm acrylic, or is it set, I don't know. So I'm going to sit here, minding my own business, designing some pulleys that will push over this, and I can then turn down on the lathe. And the plan is a hole here, or a slot, a pulley there, go back a bit, a pulley in the middle quite close, pulley quite close in the middle, another pulley at this end, so that the chain comes up here, along here, and very tightly, closely here, because then I'm going to design. Anyone else would hate this, but it's a Sunday and I love to sit here and work out, because as you know, when I've used the smaller chain, you have to be really precise when you design the pulley, the little notches in the pulley that the ball chain goes round, and I'm really looking forward to doing that. I need to get out more. Look what I've come up with, dear friends. I have a design for a pulley. Now the inside was the size of that bearing, the white one. The outside though is intriguing, and the reason it's that shape, I can't see what I'm doing now, is that the jaws on, there we are, the jaws on the chuck just fit inside that, and then I can open this and not close it, open them like that. That's now fixed on, and I'm using that bit just to cut a beautiful little groove in it. Ta-da! Look at that. Yeah, perfect. Just enough room for some glue around it. And the chain, yeah, that's lovely. The 4 pulleys are gluing in, and I'm going to work on the large one with all the dips in, sort of for the friction. And I've just discovered, I've picked this out of my bin of excitingness and found it is perfect for 2 of the balls to line up. So now by counting how many balls, and I've done this so many times, I think I remember how to do it now. That's going to be the inside diameter. I'm going to draw a little sort of bit that fits in the bottom half of one of these balls. I'm not making any sense. And then copy that around the outside, the right number of balls there are, and it should work, as long as I keep this inside diameter right. So there's 44 fitting around the outside, so I've worked out the diameter of the balls, drawn them, copied one, and then that's the only bit I want. Stop the patterns, that bit, and I've just copied and pasted it 44 times round. Hopefully I'll cut this out of cardboard, call me old-fashioned, first, just to check it does indeed fit. This ply cuts really nice and quickly. It's better, but it still needs a little bit less. There you go, 0.05 inner, okay. And it's a very old, lovely XP computer this, so it's a little bit slow. There, I've drawn a green line just inside. Get that cut out, I'll try that one. That's better, fits perfectly. It's time to sort out how to actually string all this together around this bit in the middle. And the great thing about ball chain is it can change direction, unlike normal chain, sort of. Anyway, give me a moment and I should be able to explain more clearly. It's confirmed. I'm an idiot. Look what I've just spent 2 hours doing. Look at these beautiful slots that I've cut and drilled into and everything else. This one's good. This one will lift a weight up and down this side. This one's good. This one allows the ball chain to pull up and down in the centre of that in the right place. These two, what an idiot. Can you see where I've gone wrong? This chain is going to go across the top, and these 2 pulleys are going to be mounted on brackets. What an idiot. Stupid. But this is the thing when you make something with absolutely no plans. Time to take the dog for a walk and have a good long think about my behaviour. Invisible mending service, I hear cry. Yes, bit of wood filler. This is better. Now look. Oh, see, isn't that lovely? I have managed to get these positioned in the right place. You can see the wonder of ball chain. It can change in all sorts of directions. So that's great. Now the next thing obviously this is going to work a mechanism, but it only needs to work it when it's going that way, clockwise. That's right. Look what arrived in the post this morning. It's a magical piece of wire. Look, you can bend it. It snaps back. It's actually 50 2mm by 1mm neodymium magnets. That's absolutely incredible. Now, I had a reason, of course, for buying these. They were dirt cheap. I think it was £3 for 50 of them. Amazing what you can get these days. Because I was making that ratchet that I need, and I suddenly thought, well, why not? Rather than having springs and things, I was considering using, making a 3D printed spring or something. Why not use two opposing magnets? And look, it works beautifully, Tubbs. That's fantastic. I'm so pleased with that. Because now I can get this. It's actually coming together. It's all a bit daunting, every part of this project, because I don't know what I'm doing next. I'll get that on the spindule and see whether it works. More clicky, turny things. Lovely. So, we have the unadorned keyhole, coin slot. We have the ball coin lifter. We have the handle. We have a ball chain. And then we've got a nice little arrangement of wheels and pulleys with a ratchet on it. Yeah. And then it carries on down here with temporary counterweight. I'm trying to slow this down as it releases, and I thought I'd just try the motor one last time with two lots of gears, and it didn't touch the sides really because the rubber bands were slipping, so it wasn't properly taking all the motion onto the spindle of the motor. So I thought just one last experiment, just one last one, is to have a big gear made with 200 teeth gear fixed onto the back of it, and a very small gear fixed onto the motor. You wouldn't normally do this way because you wouldn't ever have a gear that big. You would just basically have several gears with their ratios adjusted accordingly. But just as an experiment, I'm just going to start with a really big one and see, with it not being able to slip, whether it will work. Look, it's just been cut out on the laser cutter. A really big gear. Now, I've made this out of wood because I don't want to waste a large piece of plastic, as this is just an experiment. And it's worth doing all this, I keep telling myself, because I'm learning loads by doing each of these experiments, so it's worth it. It is worth it, yes it is. Here we are. There's the gear. A nice big gear. And there's a couple of little gears on the motor that is dutifully short-circuited. So let's try it. Then so we lift that up, that spins round, and then right, so it makes absolutely no difference at all. I would have thought that would have had a little bit more oomph to it. I suppose it's, now I've got that heavy weight on here, it's just not having any effect at all. Another day, and one final plan, because I was lying awake last night like you do, thinking there's got to be a way, and I realised, of course, that this gear has got 200 teeth, that's got 20 teeth, so there's only 10 to 1, or 1 to 10, that's right. That's only going 10 times faster than this. That might not be enough to get the motor to kick in properly, so I'm just cutting out a 10 tooth gear, so that'll be 1 to 20. Worth a try, why not? And I was starting to look up and think about using the reverse shallow cut worm drives like they use on music players and things like that, or there's the sort of governor, centrifugal governor like they use on the old dial telephones. Lots and lots of ideas. And I even last night had a bath, which is always fatal because I've got time to think even more, and thought, well, I could treat it like an educational thing and it could have all of them combined. No, but then I thought, I've got this lovely motor. It's a stepper motor and it's a good quality one, and it turns really nice and smoothly, and I short-circuited all the wires together and it practically stopped and was unturnable. So that is exciting. So what I'm going to do, before I do the 10 tooth gear, I'm going to fix that onto the end of this shaft with no gearing and see what happens. Join me, will you? Let's have a look and see. I'll try not to get in the way. Doesn't make any difference again. There's just so much torque created by that weight falling on here, so it's not surprising. That even this won't slow down. It's difficult for me to turn with these joined together. So, yes, that's definitely the end of this video. I could carry on rambling, but I'm not going to. Please let me know your ideas about how best I could slow down this mechanism. Use some sort of regulator. I look forward to your suggestions because I'm not all out of them, but I've obviously missed something. So even think about using a metal disc instead of that gear and using two powerful magnets to create eddy currents to slow it down that way. But having seen how... Well, anyway, stop it! Thanks very much for watching, if you're still on. Hope to see you next time. Thanks again.